Okay, next problem. We are finding the slope of the graph. So this one is actually not too bad because we have identified two different points for you to count the slope. So slope is also known as rise over run. Your change in y divided by your change in x. So we need to see how much from left to right are we going up and how much are we going to the right or to the left. So I can count and say 1, 2, 3 is my rise. And since I'm going up, it's positive. Then 1, 2 to the right, which is also positive. So 3 over 2 is my slope. I can keep counting that out. Up 3 over 2. And I can get to more points on my graph. 1, 2, 3, 1, 2. There's another point. If I'm giving a table, I can do the rate of change by calculating how much the y is changing and dividing by how much the x is changing. So it's rise over run. I'm looking at the y values in the numerator and the x values in the denominator. So I can tell that as I'm moving along my table, my y's are going up by 4. And I can also look at my table and see that my x's are going up by, oh, is it not constant? That is unfortunate. So from -1 to +1 is 2. From 1 to 4, oh, I am like missing this part right here. This is going up by 4, but this is going up by 6. And then this is going up by 4. So let's see what's going on here. This is going up by 3, then this is going up back to 2. So when it was going up by 4 on the y's, it's going up by 2 on the x's. When it's going by 6's on the y's, it's going up by 3 on the x's. Look at those fractions. 4 divided by 2 is 2. And 6 divided by 3 is also 2. Either way, we get 2. I can use the formula, the slope formula for this one as well. So I can pick any y as my y1 and my y2, and I can pick any x as my x1 and my x2, and I can do my slope formula. y2 minus y1 divided by x2 minus x1. 4 minus 0 is 4, and 1 minus -1 is really 1 plus 1, which is 2, and 4 divided by 2 again is 2. So any way that I do it, I still get 2. Domain and range from a graph. So I need to look at what's my lowest point and what's my highest point from left to right. That's my domain. So it looks like I'm starting at 1, 2, 3, 4, 5, 6, 7, -7. And I'm ending at 1, 2, 3, 4, 5. But we see that this is an open circle, so just a less than. Closed circle, less than or equal to. Okay, for my range, I'm going from the bottom to the top, lowest to highest. So my range, I'm starting at 1, 2, 3, -3, closed circle, going up to just 1, and that's an open circle. Caleb is going on a road trip. After 2 hours, he traveled 120 miles. After 6 hours, he traveled 360 miles. What's the rate of change? So we all have heard of miles per hour, right? Miles per hour. So how many miles did he travel? Well, he started at 120. He ended at 360. What's the change there? 360 minus 120 is 240. Now my hours, how did that change? From 2 to 6. That would be 4. And 240 divided by 4 is 60. So 60 miles per hour. You better slow down. You better watch the speed limit there. Okay, gym has a monthly fee of $10 and you are a member for 12 months. If the cost is a function of the number of months you're a member, find the range. Domain is your X values. Domain is your input. Range is your Y values. Range is your output. So as the months go on, you have to pay. So if you are a member for 12 months, that means you've paid $10 12 times. So when you started, you didn't pay anything. Then you paid $10. Then you paid $20. Then you paid $30. Then you paid $40. All the way up to 12 months. And those are your ranges, your output. There would be no time where you would have a charge for $5 or $5.50 or $21. It's only going to be at these specific range values, making this discrete function. So if we put this on a graph, you're not a member, you don't pay any money. You're a member for 1 month, it's $10. You're a member for 2 months, it's $20. You're a member for 3 months, it's $30. You wouldn't connect this because it's not like you have to pay 50 cents every day to be a member. At every month, you pay $10. Does this table represent a function? Well, we need to see if it passes the vertical line test. So -1, +8 is going to be like there. 0, 4 is going to be there. 2, 7, there. -1, -1, -3. Oh, nope. These are lined up right on top of each other. So that's going to be a no, not a function. We have the same X with different Y's. Not a function. Let me check my time. Okay, still got some time. Okay, if Y varies directly with X and X equals 9 when Y equals 15, find Y when X equals 33. So what we need to do is find our change in X and use that to find our change in Y. So Y is obviously getting bigger. 9 to 33. That's getting bigger. 9 times what is 33? Well, that's not something that I know off the top of my head, so bear with me while I grab a calculator. So to figure this out, sorry that looks sloppy. To figure this out, I'm actually going to do 33 divided by 9. And it is 3.666666667 is what my calculator is telling me. And we know, do we know what that decimal is? That's 2/3 if you didn't.
I
No.
have to tell would be something. They have full stuff for you.
Okay. So 3.66667 is 3 2/3. So we need to do the same thing with the Y. If Y is 15, then we need to now find the bigger Y. So I need to take my 15 and now multiply that by 3 2/3. And I get 55. Okay, in a sequence of numbers, a sub 2 is 3, a sub 3 is 9, a sub 4 is 13, a sub 5 is 18. So I'm going to take those numbers and I'm going to kind of put those in order. So a sub 1, I don't know. A sub 2 is 3, a sub 3 is 8, a sub 4 is